Hello everyone. Today I'm going to discuss about why we need modeling and what is UML. So before getting started with UML, let me give you a brief introduction of why we need modeling. A software organization, any software organization, it can be successful only if it is going to deploy quality software. Uh, Quality software means that it meets the needs of its users, what all the user wants, and it is satisfying the requirements of the user. And to develop such quality software or to deploy a good software, modeling is the central part in a software organization. So we build models. Why we build the models? We build the models to communicate the desired structure and behavior of our system. And we build models to visualize and control the system's architecture. And we build models to better understand the system we are building, and often exposing opportunities for simplification and also reuse. We build models to manage risk. So these are all the things that are adopted by most of the successful software companies. Unsuccessful software projects fail in their own unique way, but successful projects are alike in many ways. There are many elements that contribute to a successful software organization, and one common thread is the use of modeling. So you can just understand modeling like how maybe you want to build a house for your family, and you don't straight away jump into bringing a pile of lumber or some nails and some few basic tools, and you don't start constructing the house. What you do is you make a blueprint of the plan, and then you start constructing the house in the similar way. Okay, in case if the house didn't come well, it's your money, so there is no problem. But if you want to build a high rise office building for somebody else, then it would be stupid if to bring the pile of lumber and nails and basic tools and start constructing straight away. So you have, because somebody else's money is there, so you need to be very careful, and you need to prepare in such a way that there may be changes in the plan also, like the size, shape, and the style of the building. Maybe it may change also. They may change their mind even after you have started building. So all this, to accommodate all this, planning is the best approach. And you need to plan it by creating the blueprints. And modeling is a proven and well accepted engineering technique. So we build architectural models for the houses and all that. In the similar way, like you need to why you're making these architectural models of houses is that it will help the users. Who are all the users? Like the person who wants to build the house, and the person who is investing the money, and the persons who are helping you to construct the house. So all these people can have, these are all called as the stakeholders. They can have an idea or visualize the final product. By the blueprint, they actually visualize the final product. We may also build mathematical models in order to analyze the effects of winds or earthquake on our buildings and all that. So modeling is not just part of the building industry, but it is also a part of the software industry. A model is a simplification of reality. As I already told you, we build models so that we can better understand the system we are developing. And so the use of modeling has a rich history in the engineering disciplines. So it is used in aeronautical industry, and it is used in many other, like in the share markets, to understand automobile industry. And also it is also used in tunnel models and all that. So all these are uh, the industries where modeling is being used. And also in software industry, we also use the modeling. So we need a language that addresses the different views of a system architecture as it evolves throughout the software development lifecycle, SDLC. And one such language is nothing but UML. UML is a modeling language. So it's a unified modeling language. So I already told you what is meant by a model. It is nothing but a blueprint, creating a blueprint. So is a standard language for writing software blueprints, for especially for the software blueprints. So we'll be using UML. So UML is a language for visualizing, specifying, and constructing and documenting the artifacts of a software intensive system. So what is meant by an artifacts? Artifacts are requirements. They can be the requirements, user requirements, then the architecture, then the design, source code that you're writing, and the project plans, test prototypes, and releases, release documents, and all that. Anything can be considered to be an artifact. So some things are best modeled or expressed textually, which are done so in by using the programming languages. It can be Java or C++ or Visual Basic or anything. So by using that, you can express textually. Okay, so UML is a language for visualizing. So I'm explaining you what is meant by visualization. So some are best modeled graphically. So that is what is meant by visualization, which are done in UML. And UML is a graphical language. So you will be having notation symbols and here. So by using the symbols, you will be drawing the diagram. An explicit model facilitates communication. So everybody in the team can understand by just looking at one particular diagram. Modeling yields an understanding of a system. A UML is having bunch of symbols, and behind each notation there is a well-defined semantics. Each and every symbol, for example, oval, it's representing use case. So everything has got a rectangle with 3 compartments is representation of a class. So everything has got its own meaning, and this is what is meant by visualization. It's a graphical tool. And specifying means building models that are precise, unambiguous, and complete. So we'll be building the models which are complete models. Like by using various diagrams, you'll be able to visualize the entire software product. And UML addresses the specification of all the important analysis, design, and implementation decisions that you make that must be made in developing and deployment a software intensive system. So all the decisions that you are making as a team, so those will be, it makes sure that those are reflected in the diagrams. And it is possible to map UML model to a programming language such as Java, C++, and all that. So this is what is called as constructing. Constructing is mapping the UML model to the programming languages. And finally, the documentation. UML addresses the documentation of the system's architecture and all of its details. So this is the basic definition of the UML. UML is a language for visualizing, specifying, constructing, and documenting the artifacts of a software intensive system. Where can the UML be used? Okay, so UML is already being used in enterprise information systems, banking and finance, financial services, telecommunication, transportation, defense, aerospace, retail, medical, electronics, scientific, and distribution web-based services. So it is used here for modeling the software. And what are the various building blocks of the UML? So there are 3 building blocks of UML. So for first one is things, and the second one is relationship, and the third one is the diagrams. Things means that it can be a class, an interface, use case, component, and node. All these are considered to be things. Abstractions in the model. Okay, everything, all the abstractions in the model are considered to be things. Relationships are the associations between these things, okay, between the classes and between the use cases and all that. So examples of relationships are dependency, association, generalization, specialization. All these are the examples of the relationships. It's are tied together in with the relationships. And the third one is the diagrams. Diagrams are like a group interesting collections of things. So you'll be segregating them based on their functionalities, and diagrams help you to do that. And what is meant by a diagram? A diagram is a graphical representation of a set of elements to visualize a system from different perspectives. A diagram makes up a system. It is a combination of things and relationships. So there are 9 diagrams that UML provides us. These are the most common diagrams I'm discussing. There are the other diagrams as well. So the first one is the class diagram. Class diagram shows a set of classes, interfaces, and collaborations and their relationships. It addresses the static view of the system. Generally, the class is represented with a rectangle and with the 3 compartments, where the first compartment will be having the name of the class, and the second compartment will have the attributes, and the third compartment will be having the operations in it. And the next one is the object diagram. So the object diagram shows a set of objects and their relationships. It represents the static snapshot of instances of the things found in the class diagram. And the third diagram is the use case diagram. This diagram shows a set of use cases and actors and their relationships. Use case diagrams addresses the static use case view of the system. These use case diagrams are important in organizing and modeling the behavior of the system. So like use case diagrams generally tell what are the system user actions and the system responses. So you will be able to identify the requirements of the users or the functionalities that the user will be performing by using the use case diagrams. And the next diagram is the sequence diagram. Sequence and collaboration diagram can be viewed together. So these two diagrams are the dynamic or the interaction diagrams, which are used for the same purpose. So sequence diagram, as I said, it's an interaction diagram. And so here it will show the interaction consisting of set of objects and their relationships. And the objects generally do communicate by sending messages between them, and that may be dispatched among them. Okay, so the messages they send and receive messages from the two objects communicate. It addresses the dynamic view of the system, and it emphasizes the time ordering of the messages. So the sequence diagram will show the time ordering of the messages. And next is a collaboration diagram. It's an interaction diagram and also a dynamic diagram. It emphasizes the structural organization of the objects that send and receive messages. Here, the difference between the sequence and the collaboration is that sequence will have this time ordering of the messages, but here in collaboration, you don't have that kind of sim lanes and all that, but the messages will be numbered. So the first message will be having one, and the later will be having two, and the later will be having three, and so on. So that's the difference between the sequence and collaboration diagram. And the next one is the state chart diagram. State chart diagram shows the state machine, which consists of states, transitions, events, and activities. It addresses the dynamic view of the system. They are used in modeling the behavior of an interface, class, or collaboration, and emphasizes the event ordered behavior of an object. So here, what are all are the states of a particular application? All that states will be listed in the state chart diagram, and there will be communication here, transition line between the states, and this transition line will tell what is the event that has occurred, which made the application to move from one state to the other state. So that is regarding the state chart diagram. Now, activity diagram is a special kind of state chart diagram that shows the flow from activity to activity within the system. So it addresses the dynamic view of the system. This diagram is used in modeling the function of the system and emphasizes the flow control among objects. So the activity diagram will focus on the activities that made one state, the transition of the object move from one state to the other state. So that activity will be focusing in the activity diagram. And the next is the component diagram. So this diagram shows the organizations and dependencies among set of components. This addresses the static implementation view of the system, and they are related to class diagrams. Component means like what is meant by a component. It can be one or more classes, interfaces, or collaborations. A component is a physical and replaceable part of the system. For example, you can say complex components, Java beans, artifacts of development process such as source code files, etc. All these are considered to be a component. Component is a physical packaging of logical elements such as classes and interfaces. Next comes the last diagram is the deployment diagram. So this diagram shows this configuration of runtime processing nodes. So here more than one component group together, it forms a node over here, and the components that live on them. So in the nodes, like you can have more than one component. So they address the static deployment view of the architecture. They are related to component diagrams in that a node typically means one or more components. A node is a physical element that exists at runtime and represents a computational resource. generally having at least some memory and processing capabilities. So it's a physical element. Node is considered to be a physical element, but component can be a logical entity. It can be a source file. But coming to this particular deployment diagram, a node means that it's a physical element on which this component will be deployed. Okay, so a set of components reside on a node. Friends, welcome back. In today's video, I'm going to discuss state chart diagram. A state chart diagram is a pictorial representation of such a system with all its states and different events that lead transition from one state to another. So let me give you an example of a state chart diagram. For example, consider a computer, any PC that you're working on, or any of your laptop or anything. Just consider a computer. What can be the possible states in the computer? The possible states can be the running state of the computer, shutdown state of the computer, and hibernate state of the computer. So what is the transition? Is transition is like a from the running state to the shutdown state. There can be a transition from the running state to the shutdown state. So when do a system go from the running state to the shutdown state is when the user presses on the power of switch, or he just takes the shutdown option from the menu displayed by your operating system. So by doing any of these activities, the system will go from one state to another, which is like the running state to the shutdown state. So here this running is called as a state of the machine, and this shutdown is also called as the state of the machine. And what is the transition here? The transition is when some event has occurred. What is the event here? That the user is pressing on something. When the user is pressing on power off switch, or the user is clicking on the option from the menu, which is shutdown and all that. So here, these are the external events that are causing the machine to go from one state to another, which is meant by transition from one state to another. So this is a general example that I can give you for the state chart diagram. And the state chart diagram have got certain building blocks. What are they? So they are like, there can be three states initially. The first state is the initial state, and the second one is the final state, and the third one is the intermediate state. So you have what is meant by initial state. It is like the state in which an object remains when created. So that is an initial state, and final state is the state from which an object do not move to any other state. So that is called as final state. And any state which is neither initial nor final, it is called as an intermediate state. The initial state is generally represented with a circle filled with black, and an intermediate state is represented by a rectangle with rounded corners. As you can see here, like off is a state over here, and this off is a state which is represented with a rectangle with rounded corners. And the final state over here is, and you can see this is an intermediate state, and this solid circle is called as the initial state. And you can see that there is a state over here which is the final state. Final state is represented by an unfilled circle with an inner black filled circle. So this is the final state. The intermediate states, like which are rectangles with rounded corners, generally have two compartments, or for simplicity's sake, you can just keep it with one compartment. When it is having two compartments, the two compartments are separated by a horizontal line, and on the top of the compartment you will be writing the name of the state, and the name of the state should be very short and simple, and it should be a descriptive string. So here the name of the state is serving customer, so we need to make it very simple and short. And the internal transition compartment, this is the internal transition compartment wherein you have this entry, exit and all that. So this entry, these are the labels. Okay, so there are four labels: entry label, exit label, do and include label. Entry label indicates activity performed when the system enters the state. Okay, so as soon as the system enters into the serving customer state, like what are the activities that it is doing? So it is reading the card. So this is the activity that the system is doing. And this exit is another label which indicates that indicates activity performed when the system exits the state. Okay, so when it is coming out of this particular state, when it exits the state, like what the activity that is performed. Like you can say eject card is the exit activity that this particular state is doing.
And a do is there. Do indicates any activity that is performed while the system remains in this state. So that is do. Do is the activity that it will be performing in this particular state. And next is include. Include indicates invocation of a submachine. So for example, in case this particular state is invoking some other sub activity, then we'll be mentioning that as with the include label. So these are all the four labels, special action labels that you can use inside your intermediate states. What is meant by transition? Transition, this line that we are seeing here, a directed line that we are seeing here, is called as the transition. Transition is movement from one state to another state in response to an external stimulus or an event. Not only the external event, even it can a state can the object can move from one state to another state with an internal event as well. So the transition is represented by a arrow from the current state to the next state. So here, if you can see that out of service, from the out of service, it is moving to the off state. Okay, so that it's a directed arrow. So what is an event? Event is what is causing. Okay, so the action that is causing a transition. So this event need to be written in the past tense, and it is mandatory for each and every line, transition line that we are drawing. You need to compulsorily write this event name. What event is making the object to go from one state to another state? And also you can write some preconditions which must be true for the transition to happen. Like the conditions, you can also mention the conditions for moving from one state to another state. So these are all the, building blocks of the state chart diagram. Now let us look into this particular example. So I'm giving you an example of the state chart diagram for the ATM machine. So this is how you draw the diagram. You can draw the diagram in star UML, or you can also draw in online tools which are like Lucid Charts and all that. So you can see that this is the initial state. The solid circle over here is the initial state. From this initial state, like you can see that there is a state which is mentioned as off state. Okay, so this is the off state. And from the off state, it is entering into the test state. When it is entering, so there is a transition over here, which is turn on or start up. Okay, so somebody externally is coming and switching on the system. So when somebody comes and switch on the system will go from the off state to the self-test state. So from the self-test state, again, it is going into the idle state. Idle state is like it goes, like if no customer is using the system, it's going into an idle state to efficiently use the resources. It is going into an idle state. And from the idle state, when the person is inserting, if any customer comes and inserts a card, from the idle state, it is entering into serving the customer state. So here you can see that here, as soon as you can see read card, because the customer has inserted the card. So as soon as it enters into the serving customer state, it reads the card. Okay, and after that it processes it. It can be any operation that the user is talking about. It can be withdrawal, or it can pin change, or it can be balance inquiry. All that operations it's going to serve. So serving the customer can include all the operations that the bank is providing. And sometimes this reading card can have some issues. So it can also be a cancellation of the transaction. So again, we can see that the transition from the serving customer to the idle comes because there is a cancel transaction. And this arrow mark here shows that it is a successful transaction. And after this, what happens in case if there is some service done by the people of the bank, then it is going from the idle to the maintenance state. From the maintenance, after some bugs repair and all that, then it is again entering into the self-test state. And from this test state, maybe there is some failure occurred because of the hardware or the software failures, external failures, or any internal failures. Then it's going from self-test to out of service state. Okay, so from the out of service state, like if the person is switching it off, it is shut down, then it goes into the off state. Okay, right. And in case while serving the customer, there is some hardware or software failures, other than the card issues of the customers, then you can see that there is a transition over here which is saying failure because of some internal failures or the external failures, hardware or software failures, or some power cut, or any power supply failure and all that, then it is going into out of service. So from the idle state, if it is turned off, again it is going to the off state. Okay, so I hope this diagram is clear to you. So this is how we draw the state chart diagram. So you can also see that these are the intermediate states over here, so which are put in the rounded rectangles, and this line over here is nothing but this line here. Okay, so all the lines, that the directed arrows that we are seeing between the states is called as the transition. And on top of the transition, like the failure and the service, all these labels that we can see are nothing but the events that have made the system go from one state to another state. So this is all about the state chart diagram.